Welcome, and we're back with a couple of your practice problems for your Newton's first law understanding. So we're going to be looking into average velocity with this one. So let's jump right into it. A student walks to school, non-common thing. When they have gone 50 meters over the first 10 minutes, they realize they left their homework at home. They run back 30 meters only to find their homework is in their folder because they are a good student who uses one. After 4 minutes of running, they then proceed the rest of the way to school. So, our questions are finding the average velocity for the student over the first 10 minutes, over the next 4 minutes, and then over the entire 14-minute excursion on their way to school. So what we're looking for is average velocity. So in order to be able to find that, we need an equation. So our equation, as you've learned in class, is the average velocity is equal to the displacement over time. That's what that delta x stands for. It stands for displacement. So we need to know how far they went, because displacement is where they ended up compared to where they started. So we know that they went 50 meters in 10 minutes. So if we do a simple division right there, 50 divided by 10 gives us 5 meters per minute. Now, a special note with this one, we have just stated our frame of reference for this one by saying that's 5 meters per minute there. We are saying that towards the school is positive, and that away from the school would then therefore be negative. This will come in handy when we get to our next question, part B here. So when we get to the next question where they are backtracking over the next 4 minutes, we can see that the next part should be negative 30 meters that they walked back, and that was over 4 minutes, which gives us an average velocity of negative 7.5 meters per minute. Now this may sound a little bit weird, but that's because we are used to the terms of speed. Speed cannot be negative. Speed is how fast you're moving regardless of what direction you are going, and it depends upon your distance covered, not your displacement. It does not care about what way you went, just that you went it. Average velocity is more useful for being able to determine where you end up. So the very last one, average velocity of the student over the entire 14 minutes. When we take a look at this, we have displacement. Now displacement is where are we, right? So over that 14 minutes, they have gone out 50 meters, but they have also come back 30, which means that instead of it being either one of those or the addition of them, because they're coming back, they are subtracting that off. So that leaves us with 20 meters over 14 minutes, which comes out to being approximately 1.43 meters per minute. Okay. Now, you could have converted these into meters per second because that's fairly common and that's usually what you want to do, but there's no imperative to do it here. We're not working with any constants, so we can leave it in meters per minute. Always try to remember that if you are going backwards, that will detract off of the value. I will see you next time on our next little practice problem, which will be coming out very shortly along with this one. See you in a few, ladies and gents.